All right, hello everybody. So in this video, I wanted to show you how you can use a compass and a straight edge to make a Voronoi diagram with a couple points. And I'm using GeoGebra, but you can do all of these with just our compasses by making circles and then connecting dots with a straight edge. So when you're doing this, the circle with center tool that I'm using on GeoGebra is just like putting your compass's pivot point. So you put the pivot point on A, and then you can spin it around at any distance from A. So you make your distance from A equal to the distance AB. And that gives you a circle. So every point on that circle is the same distance away from A. And you play the same game with just the center on B and the radius of AB. And so now all of these points that you created are the same distance from A and the same distance from B. I should say the intersection point is the same distance from A and it's the same distance from B. So if you've got your segment AB, you can draw a new segment that connects where those two circles intersect, and that new segment is a perpendicular bisector. It's the same distance from A and B, and it cuts them at exactly a right angle. So now we're going to play the same game that we just did with points A and B. We're going to do that with C and with B. So I put the center at A, and I put the radius at C. Now I'm going to do the same thing, put the center at C and the radius at A. And I'm looking for where those two circles intersect. I've got A connecting to C, and I've got their circles over here coming up, and their circles intersecting right there. And you can see that that is also a perpendicular bisector. It cuts AC in half at a 90-degree angle. Let's play that same game one more time. We've got a center of B coming out to point C. We've got a center of C coming out to point B. And we've got those two circles intersecting here. And where's the other point that they intersect? Is it here? It's hard to see. No, it's here. Yeah, because that is on the circle that is centered at C, the inner circle, because there's two circles centered at C. It's at the inner circle centered at C and the outer circle that's centered at B. So I almost did that wrong. It can get a little complicated with this many circles on there. So something that's helpful is noticing that there's two circles at each of the points, and so you can say, oh, it's the inner circles that I'm looking at now, or it's the outer circles I'm looking at. So, or if you're doing this by hand, you can use different colors to draw the different circles to keep track of which ones connect with the other ones. The other thing that you should always just be able to do visually is if you draw BC, you kind of know what the perpendicular bisector should look like. You should know it hits in the middle and it should hit at a 90-degree angle. So one of the cool things about this then is that all of your perpendicular bisectors are going to meet at one point right there. And that point is usually called V for vertex, and it is the point that is the same distance away from A, B, and C. In fact, you can put a center at that point, and if you draw it out, you'll see that that circle touches all three of the original points, A, B, and C. So then this is what's called a Voronoi diagram. And it's called a Voronoi diagram because we've actually divided up all the space into sections. And if I go from that vertex and I go along this perpendicular bisector here, that gives me the boundary between A and C. This perpendicular bisector gives me the boundary between B and C. And this perpendicular bisector gives me the boundary between A and B. So you can imagine there's a lot of situations where you might want to know what is closer to a certain point. So if these were, for example, schools is an example I've used a lot. If this was high school A, everybody who lives over in the red region lives closer to high school A than to high school B or to high school C. Everybody up here in the orange region lives closer to B than to the other high schools. And everyone over here in the green region lives closer to C than to the other high schools. So let's say that you had a new high school was to be built in this area. So let's put a new high school on here. So just to reiterate, we've done a Voronoi diagram for 3 schools. Let's add a 4th school and see how it changes the picture. So if I put a 4th point, let's just say it's over here. This point is farther away from my orange zone, so I don't really need to worry about the orange zone. I'm going to worry instead about how this affects the green and the red zones. So I'm going to erase some of the stuff around here just so we can see what's going on. And I'm basically going to do the same thing one more time just to see how my new school, which is called K, is going to affect the red and the green zones. So let's do circle with the center at K, going through A, and then A, going through K, and let's draw our perpendicular bisector. So K to A. And then over here on the other side, K to A. All right. Now I'm going to find the perpendicular bisector between K and C. So K and C, K and C. And I'm going to find the connection between those. So here is the circle K going up until it hits the circle on C right here. And the circle K and the circle C right down here. And so what we have now is a new V point. Let me see. Okay, so what we have is a new V point right here where our bisectors hit each other, and we have a new perpendicular bisector between K and C, and a new bisector between K and A. So what we've done is just carved out this little zone down here that is now closer to K than it is to C or A. And so we can shade back in, okay, here's the green zone. Everybody down here is closest to high school C. Everybody down here is closest to high school K. And I didn't need to worry about the orange zone because that was definitely further away. So every new point that you add in, you just need to look at what cells are closest to that point and then play the same game with your perpendicular bisector there and then shade in the resulting areas. All right, so please comment and ask questions if there's anything that you want to know. I hope you can see how this is a useful idea when you're looking at a map and trying to figure out what is the nearest neighbor to certain things.